Hi all, welcome to a very exciting video which complements our EKS Anywhere Saga series blogs. And in this video, we will actually advent the use cases for GPU on EKS Anywhere clusters. And you can actually fathom the fact that, this is the most important trend in the industry where GPU-based applications, whether it is about data engineering or data processing, or training of models and inferencing solutions, all encompass are actually looking to find a safe home, which is on Kubernetes and on top of GPU-enabled hardware, right? And this typically brings forward a very good use case for EKS Anywhere on bare metal, where we can exploit the performance of the bare metal with GPU-enabled cards, and then look to actually enable all the use cases on top of that. In this specific video, this would be the first stepping stone to actually make it happen. And then thereafter, Raj, myself, hi Raj.
Hi everyone.
We will actually then start coupling many additional use cases once we've got the the primitives in terms of the GPU setup on a EKS Anywhere cluster. So in the previous video, you did see how do we create the EKS Anywhere clusters on bare metal with Ubuntu and with Red Hat, right? So I'm not going to go through and steer through those complexities here or those steps. In this specific case, we already have, actually yesterday we built an EKS Anywhere cluster on bare metal, and I'll just show you. It's a fresh cluster. And what we will deploy is the first stepping stone is the deployment of the Nvidia GPU operator. So before we delve into that, let me explain you the setup that is currently existing in our lab environment. Let me put it into the slide mode here. Okay. So here we have, it's a 3-node cluster, okay, with 2 worker nodes, which are Dell R760. And both of these worker nodes are actually loaded with NVIDIA L40S. Again, bigger the better. You could have, the H200s and A100s and whatnot, but right now, in my specific lab, the GPU cards are L40S. And 2 GPUs on the first node and 2 GPUs on the second node, right? Other than that, I think you are familiar with, how a typical EKS Anywhere on bare metal looks like. You have the admin server, a web server to actually stream the OS images when the nodes start booting up and things like that for the first time install. You have the control plane and the worker nodes, right? And all of them basically are right now in the same layer 2 broadcast domain and things like that, right? Now, the point is that what we will be doing is, like I said, deploying the NVIDIA GPU operator on top of this EKS Anywhere bare metal cluster. So if you look at my PuTTY session, which is right now inactive since this was done yesterday, we went actually ahead deploying a EKS Anywhere cluster, okay? And you can see that the cluster has got successfully deployed, created. And like I said, we're not going to go through the entire, additional effort of doing it because, you've seen that in the previous video, hopefully. Now, let's start by looking at a terminal where I will start first with exporting my kube configuration. Okay, so let's do that. I'll export the kube config so that I can show you the node information that is there. So kubectl get nodes -o wide. And we can see that, this is the control plane node, and these are the 2 worker nodes. They are all running version 1.30 of Kubernetes. They are loaded with Ubuntu 22.04. Let me also say kubectl get hardware minus A. Okay. And let's just supplement it. Show labels. Sorry. Let me just punch out the label. Sorry about the dash O there. So we have the hardware information. I mean, the hardware.csv, the inventory file that bears this configuration to create the cluster. So we can see that, these are the three nodes, and this is what the hardware inventory talks about the Tinkerbell. Yeah, so practically this is about it. And then, let's look at the nodes themselves actually in the iDRAC console. So we have the worker node here. Let me just refresh this. All three of them. Okay. Let's log into the nodes to see the GPUs. Okay. So the worker node as such, the control plane node as such does not have any GPUs on it. Okay, and we can check it here. Okay, so the GPU is missing on the control plane node, on the worker node 1, and we can look at the accelerators. So we can see that there are two GPUs for Nvidia L40S. And likewise on worker node 2, we should have the two GPUs of L40S, right? So primarily an EKS anywhere cluster with two worker nodes, bare metal, with L40S Nvidia GPUs, right? Now, before we start deploying the Nvidia, see, importantly, when you have the GPU cards available and you want basically a Kubernetes rendered platform to avail the GPU cards and the applications running through that Kubernetes platform, essentially you need to marry the CUDA, to the upper layer of abstractions, right? In the Nvidia paradigm, the Nvidia GPU operator brings forth the cumulative of different I would say software components which are actually required to be steered along for this to happen, right? So if you look at my picture, in a traditional sense, you need the access to the underlying CUDA kernels. So you need the NVIDIA drivers to be installed on a server hardware, let's say. Plus, in addition to that, if you look at the different components here, the driver container, the container toolkit, the Kubernetes device plugin, the DGCM exporter, the GPU feature discovery, and the MIG manager. These are actually all separate components which run as containerized applications on the Kubernetes cluster. And in totality, all of these combined together give you access and different dimensions to actually operating with the NVIDIA GPU cards actually, right? Specific information in terms of what each container does is mentioned here. For example, the feature discovery will detect the GPU model and the specific features of that underlying hardware and things like that. It will label the nodes by GPU features and things like that. The driver container obviously, loads the NVIDIA GPU driver and, other things actually. Why am I talking about this is because in the, let's say in in the earlier era, when things started spawning up, these containers had to be actually individually installed on a Kubernetes cluster, right? And now you have a composite, which is called as the GPU operator. And again, look at the clear problem statement, right? If you were to do these things individually, the configuration and the dependencies that actually come along, such as identifying firmware versions, the runtimes, and the other library dependencies and all that, it could be a issue of sort in terms of marrying together multiple components in a very streamlined fashion. And that is where the magic wand of the Nvidia GPU operator comes into play, where one installation takes care of installing all of these components in a structured and seamless fashion, actually, right? And hence gives the ability for your GPU based containerized applications to run on top of any Kubernetes cluster, right? And that is what we are going to do in this particular video. So let's start with doing that. As such, if you look at it, we've gone through this. We can always label our node. So let's do that. These are labels that you can put on the node just in case you want to actually, do pod segregation and all that by node selectors or node name and all that, actually, right? So let's go ahead and label our nodes. I'm just putting a label. You can choose whatever labels you want to put there. Now, the process to install the Nvidia GPU operator as such is very simple. So we add the official Helm repo. Okay. And while we are getting the updates, the command to install the Helm repo is helm install void generate name -n GPU operator, create namespace, and this is the Helm, right? Nvidia/GPU operator. Okay. If you already have installed it and you want to upgrade it, then I've also given you the command, in terms of what needs to be done there. For now, we just will go ahead with installing the GPU operator, and you will see the magic in action there. Okay. So let me clear the terminal. And let's go ahead and install the GPU operator. Now, this could take about a couple of minutes, depending upon, fetching the image and things like that. So I'll just kind of, pause and resume when it's installed fully. So we can see that the GPU operator is installed, but obviously the pods will take their own sweet time to come up. So let's just see if the pods have come up. The namespace is GPU operator. Okay. So again, some of the pods are still, now while this is happening, it's a good time to kind of reflect upon what I said in the slide. If you look at the components here, let's start with the driver container, right? This is one of the, now, because I have two nodes, okay, ideally, the GPU related, pods or daemon set should only run on those specific two worker nodes which have the GPUs enabled, right? So how does it all start is basically, it starts with the GPU operator, right? And GPU operator basically leverages the node feature discovery, which is another sort of application or containerized workflow, which actually tries to, or which gives you access to the underlying hardware and its feature set, on all the nodes actually, right? So you can see that the Nvidia GPU operator leverages the node feature discovery to actually first go and see which all nodes have the GPUs available and things like that, right? And then starts the GPU feature discovery. Basically, it will go ahead and label those particular nodes. So you have two feature discovery pods there, and you can see that loads the feature discovery, detects the GPU model specific features, labels nodes by GPU features and all that, right? Next is basically the you can see the driver here. Now, obviously, this driver, depending upon, which is the which is the hardware installed and which is the version and things like that, checking all that compatibility. So the device drivers are actually installed here. Then you have the device plugin here, which are again two pods because they are a Devon set. If you have 3 nodes, 5 nodes, 10 nodes, the number of pods will just kind of go there, right? So you have the device plugin here, which exposes the GPU to the Kubernetes scheduler, basically, right? And it tracks and allocates the GPUs in the cluster there. So that's your device plugin there. What else do you have? The container toolkit, which exposes the GPUs to containers, right, for being accessed actually, right? And it supports different kind of container runtimes. In our case of EKS Anywhere, the container runtime is container D, and then it exports GPU environment variables. So you have this particular container toolkit here, right? So container toolkit, right? Then you have, we spoke about this. Then let's talk about the DGCM exporter. Again, you can see that the DGCM exporter, 2 pods here, and they will basically, are responsible to actually expose the telemetry, with regards to the GPU pods and things like that. What else do you have, right? So yeah, the operator validator, I think it's a very important construct. The validator, can I see here? No, okay. So the validator will ensure that things are in place, and it's specifically for the operator itself to be validated, right? And while I can't see the MIG manager, but we've not enabled that, but it sets the MIG profiles, for time slicing and, multi-instance GPUs and things like that. So practically speaking, this is what the totality of the GPU operator is in this particular case. And I hope you understand the value add the GPU operator puts into play. Else you will go about, downloading these particular images or, installing them. And then, things can become a little tricky. But in this case, you can see that, your GPU operator has successfully run. And then all the pods that we need, they are in the right running status, right? With that said, practically speaking, your EKS Anywhere cluster or likewise any other Kubernetes cluster is now ready for deploying GPU-based containerized applications which have access to the underlying GPU, right? Again, like I said, the GPU paradigm has evolved so much that you can now accelerate your data pipelines for pre-post processing and things like that. You can, training obviously was always a mandate of the GPU, and also the inferencing, which you can actually do on GPUs and things like that, right? So while we will dwell with these topics and get into a couple of examples and demos in the later on videos, in this video, let's just validate now that we have the EKS Anywhere cluster running on bare metal. We do have the GPU operator installed on top of that. Now is the time to actually deploy a couple of test applications, like a Nvidia SME, which is like a command line interface to just validate, if they can access the underlying CUDA and the GPU information and things like that, right? So what we will do is okay, so we can also see the labels, which are associated. It will be a long list of items again, and this is being done by, GPU feature discovery. So you will see that there'll be a long list of labels that will get printed out. So you can see nvidia.com, CUDA runtime, version, full, major, minor, and all these things basically have been in place now, so that, when you start building your applications, the scheduling of those applications and things like that, everything is kind of, interrelated here. Now, and you can definitely, read more on their documentation website. It's a fantastic website to go ahead. What we will now do is we will render a sample application, which is a pod. And, if you look at the image, basically it's a CUDA image that has a job to completion. And that will basically run the NVIDIA SME command inside of that particular container. And what we are going to do is basically, depending upon how many GPUs you want to query, you can keep it one, two. I have two GPUs on a single node. Obviously, this is a single pod, and so it would get deployed on either of the nodes. Doesn't matter. You could, in fact, do a node name here, and in the on the spec, and then it will go and deploy on that specific node if you want to. But for now, we will just query of any particular node. We just want to see that this works. The underlying access to the GPU is available through the CUDA. So let's do this particular thing. Let's copy this particular and let's paste it here, right? So we can see that the pod, obviously, the image will take its time to download. So let me see if I can see. You can see that the NVIDIA SME container is getting created. Once it gets, obviously, there is a job that runs inside that. So, it'll basically say completed, and then we'll check the logs of that particular container. Let's just wait for the pod to get fully completed. So, okay, so about 2.5, 3 minutes, the image download and everything, the pod has finally finished its run, and we can see the status is completed, right? And now if we just say kubectl logs, NVIDIA SME minus n GPU operator. So there you have it. Basically, the ability to run a container. Now, this is a SME test container, obviously, but it does need the GPU operator to be in place so that it can do all this, information gathering. And what we have it, basically, we can see that it queries the status, basically. So you can see that you have the first NVIDIA GPU L40S and the second one also here, right? And if you work with NVIDIA SME, you can do a lot of other things, right? So, but at this stage, you should be comfortable stating that, you have deployed the GPU operator and you do have the ability to kind of, run any containerized applications that have access to the underlying GPUs as such, right? With that said, again, thanks a lot. I hope you enjoyed this short but informative video, and it helps people who are in the process of deploying EKS anywhere on bare metal with GPUs. It does help you. Okay, thank you.